Welcome to Ask and Learn.
We want to sketch the curve y is equal to 4 minus x squared to the fifth power. So in this chapter, they give us this laundry list of steps we should follow whenever we want to graph something. So we're just going to follow those steps. So the first thing they tell us is to determine our domain. Well, this here is a somewhat factored polynomial. So we know our domain is going to be all real numbers. The next thing they tell us to do is to find our intercepts. So intercepts. And let's go ahead and find our y-intercept first. So y-intercept, this is when x is equal to 0. So it's going to be y is equal to 4 minus 0 squared, which will just be 0. And so it'd be 4 to the fifth. All right. So I really don't care what this number is. I just care that it's positive or negative. So we're just going to leave it as 4 to the fifth. But you can rewrite it if you want. Next, let's go ahead and find our x-intercepts. So now this is when y is equal to 0. So we're going to have 0 is equal to 4 minus x squared to the fifth. Well, this implies that we really just have 0 is equal to 4 minus x squared, which is x is equal to plus or minus 2. And the last thing is they want us to find symmetry. Let me go ahead and move these over a little bit. Ooh. Looks like I lost my 0 along the way. All right, next. So step 3 should be symmetry. So we know polynomials are not going to be periodic, but we can look to see if it's even or odd for symmetry about the y or x axis. I mean the y-axis or the origin. So plugging this in, we're going to get 4 minus a negative x squared to the fifth. Squaring the negative x just gives us x, so we get 4 minus x squared to the fifth, which is f of x. And by f of x, I mean the function we're working with up here. So this implies that this is an even function. So we have symmetry across the y-axis. The next thing they want us to find is asymptotes. So we know that polynomials should not have any asymptotes, but we can go ahead and look at the end behavior with the same idea. So the limit as x approaches infinity of f of x. Well, this would be really, so I'm just going to kind of write, this is for very large values going to be equal to negative x to the 10. So we know it is an even degree polynomial with a negative coefficient, so this here should go to negative infinity. And since it's an even degree polynomial, whatever the end behavior is on one side, it'll be on the other. So this should also be negative infinity. The next thing we want to find is intervals of, and I'm going to combine this with step 6 also. We want to find where the function is increasing / decreasing and any local max / mins that we have. So that means we're going to first need to find what y prime is. So let's go ahead and do that on another page since this will take a little bit of work. So we have y is equal to 4 minus x squared to the fifth. Now the first thing I'm going to do is just factor out a negative from here. So I'm going to write negative x squared minus 4 to the fifth. Remember, we can factor that out since it's an odd power. All right, and I just want to do this because it'll help me keep things in place when I'm taking derivatives and stuff. So the first derivative will be, well, we're going to need to use the power rule and chain rule for this. So first we're going to have x squared minus 4 to now the fourth power, and then we need to multiply a 5 out front. Then we need to take the derivative of our inside function, which is going to be x squared minus 4. And we know the derivative of this here is just going to be 2x. So we end up with negative 10x, x squared minus 4 to the fourth. Now, we're going to go ahead and set this equal to 0 because we need to know the critical points of this to help us find our local maxes and local mins, if we do have any. So this would imply that either x is equal to 0 or x squared minus 4 is equal to 0. And once again, this is going to be x is equal to plus or minus 2. So critical points are 0 and plus or minus 2. All right, so now let's go ahead and write down what y prime is. So y prime is going to be negative 10 x times x squared minus 4 to the fourth power. Now we can go ahead and determine where this is going to be, and let me actually write this in red. So increasing, which will be where y prime is strictly larger than 0. So I just went ahead and already solved for this just to cut down the length of the video a little bit because it would take way too long to do this. So we would have that this is strictly greater than 0 on the interval of negative infinity to negative 2, and then union negative 2 to 0. And we know this is going to be decreasing when y prime is strictly less than 0. And this would just be the rest of the interval minus our critical points. So it would be 0 to 2, union 2 to infinity. Now let's go ahead and plot down those critical points we had. So we had negative 2, 0, and 2. And we know this will be increasing on negative infinity to negative 2 and negative 2 to 0. And we know it's going to be decreasing on 0 to 2 and 2 to infinity. So that tells us negative 2 is a saddle point by the first derivative test. 2 is also a saddle point by the first derivative test, since we do not have a change in the derivative, but we get that 0 here, since it's going from increasing to decreasing, should be a local max. All right, and then the last thing they suggest we find is the concavity of this and our inflection points. So we'll need to know what the second derivative of this function will be. So let's go over here and do that also. So we found that y prime is this right here. So we want to take the derivative of that. And we'll do that by using the product rule. So y double prime is going to be, and I'm going to factor that negative 10 out front here. So remember, product rule says keep the first thing you're multiplying and then multiply by the derivative of the second function. So x squared minus 4 to the fourth. And then we're going to add to this where they're switched. So x squared minus 4 to the fourth. And then the derivative with respect to x of the other function, which is x. Right, so now we already know the derivative of x is just going to be 1. And to take the derivative of x squared minus 4 to the fourth, it'll be just like before where we had to use chain rule. So the 4 is going to come out front. X squared minus 4. And now it's to the third power. Then we need to take the derivative of our inside function. So x squared minus 4. And then over here we'll just have x squared minus 4 to the fourth power. Now the derivative of x squared is going to be 2x by power rule again. And then the derivative of 4 is just 0, since it's a constant. So let's go ahead and clean that up a little bit. So it's going to be negative 10, 8x squared, x squared minus 4 thirds, plus x squared minus 4 to the fourth. So we can go ahead and factor out this x squared minus 4 to the third. And doing that will leave us behind with 8x squared plus x squared minus 4, which can be simplified down further to 9x squared minus 4. Let me go ahead and zoom out a little. So now if I were to set this equal to 0, we'll notice we have two perfect squares here. And we already know that this here will give us x is equal to plus or minus 2. And this here will give us x is equal to plus or minus 2 thirds. So factor that, since they're perfect squares. I mean, the difference of squares, not perfect squares. And it should just be plus or minus those answers. All right, so we'll need to know that there as well. All right, so let's go ahead and write down our second derivative. So it should be negative 10. X squared minus 4 cubed. And 9x squared minus 4. Now, just like we did before, we want to figure out where this will be concave up and concave down so we can figure out our inflection points. So concave up is going to be when y double prime is strictly greater than 0, and then just like before, just for the sake of brevity, we will, I'll just say where this occurs so we don't have to go through all the tedious algebra. All right, so this here will be on negative 2 to negative 2 thirds, and also 2 thirds to 2. And then the remaining interval or intervals will just be where it's concave down. So negative infinity to negative 2 union negative 2 thirds to 2 thirds and 2 to infinity. Now we can go ahead and use this to figure out our points of inflection. So before we found negative 2, negative 2 thirds, 2 thirds, and 2. Now we know this is concave up on negative 2 to negative 2 thirds and 2 thirds to 2. And it'll be concave down on the rest of these intervals. So negative 2 to 2 has a switch in concavity, so this is an inflection point. The same thing for negative 2 thirds, same thing for 2 thirds, and same thing for 2. So all four of these are points of inflection. All right, now that we have this done, it tells us we could go ahead and finally sketch it. So the first thing we should probably plot is our intercepts. And we're going to have 0, -2, and 2 for our, oh, so dot 0. Let me go ahead and get that off. Our y-intercept actually was supposed to be up here at 4 to the 5th. Yeah, and then the x-intercepts are -2 and 2. All right, so we have that. And by number 3, we know this is a symmetric function. So if we just plot the left-hand side of this, then we can just reflect that graph across the y-axis. All right, so on the left, we have our end behavior going to -infinity from part 4. So we know we need to start down here. And what other important points do we have? Well, at -2, we have a saddle point, so that means it should flatten out right here. And we know at 0 it will be a max, and we also have inflection points at -2/3. So -2/3 will need an inflection point. All right, so let's go ahead and start graphing this now. So we start at -infinity, and the first point of interest is going to be -2. And like I was saying, it needs to flatten out here since this is a saddle point. And it's also a point of where our concavity will change. And then we hit -2/3, and the concavity should start to change as well. We hit our maximum here at 0 from part 5 and 6. And now all we need to do is reflect this graph across the y-axis due to symmetry. So by 3, we can just go ahead and start doing the same thing we did before. So it flattens out here and then goes down to -infinity. So you could go ahead and be a little bit more accurate with this if you want. But since we're just trying to sketch it, I don't think we really need to add all these numbers and stuff. But you could always go back and possibly figure out like what this actual value here is for the change in concavity. Same thing on the other side, but I don't think it really matters all that much since we just want to sketch it.